Well, we're back, and here we are with Friday and Harvard 410T hand portable from 1981, and a Harvard 410T hand portable and a Harvard 410T hand portable. Customer repair, end user. Customer repair, same customer with the Bannerton Route 66, the immaculate one the other day, and the Porter Pack Midland 77205, whatever it was, a Marsh Scruffy one. Now, if these aerials aren't intact, there's no point proceeding because there's absolutely nothing we can do with the set. So, without poking the camera's eyes out, okay, so always put these down from the lowest section, not like they used to do on these TV things in the past, and whip them down from the top and smash them. So that's that, customers. I think Knights at Curtin and Lindsay was the last people to stock these aerials, and I think they dried up about 5 years ago now. So that one's alright, and ours is also fine. Now ours has got a broken case, but it doesn't matter. You see, it's got dropped, hasn't it? They're a very fragile radio, to be honest. That shouldn't be a problem, and we haven't got corroded battery contacts, which is also good. We'll do ours behind the scenes. Ours is immaterial, but it will get done on this session. So I've put a pink sticker on this customer's, and a pink sticker is going on the back, and the pink sticker's gone on his box, so we don't get backs and fronts muddled up. And it's 232. Is this penwork 731 23731 21? Can't even read. And on the other one, we'll take it out of its nappy. Now these are fun, aren't they, to get out? Poke the aerial right down, push the case so you can get the PTT bar out without ripping it, and then we'll put a yellow post. I went to Lidl and got some post-it notes, you can tell, can't you? And we will put, with the yellow pen, 50590 50590 50590. So that sorted that out. So we'll take his lid off. These are intended to do with a coin. Who remembers Kenny Everett doing an advertisement on television for these in 1981? Are they batteries? Are they dummy batteries? Hopefully they're dummy batteries. And that one's empty. So look at the corrosion. There's a little bit more corrosion in that. We'll go over it with the fiberglass brush as I'll pinch off Mr. Chippy's bench. You've got to always pray that the PA transistor hasn't died in these because it's very expensive. We do have them in stock, but they're very expensive, like 14 quid, something like that. It's a Motorola MPSU 3.1, and they were hard to get even back at the time. Mind you, I tell you what, they were about £5 something, even in 1981. So the fact they're 14 something, 38 years later, isn't actually that scary. I can't open that one. Don't know why. So let's have a look at this one. We'll move his battery door to another place. It says Neil on the inside of that battery door. That one doesn't have a name, but it's not Neil who owns it. That doesn't look like it's ever had a battery in it. Wow. Can't remember whether I unscrewed this one. No. So you've basically got the one screw holds it down, and then clips at the bottom, and then it withdraws from the top. Yes, you do have a handy high-low power switch in the back, and that's quite useful because you're wanting to talk close range, and it'll save battery dramatically. So somehow we've got to get our fingernails in here. I've done it. And then carefully withdraw it from the top. There we are. In fact, we've withdrawn the top to some extent. Carefully not breaking any wires, and then being aware of all the wires connected to the antenna and the battery, etc. So I'll put that on one side. So the one we're going to work on will be this one, only because it's the one left behind. So we'll do the customer ones. I've already forgotten which one this is. This is Mr. Immaculate Route 66. That's his new name. But it's not as immaculate as Mr. Pink Customer. I mean, what you don't want to do is to start putting tools in here to force it apart. There we are. So once again, unclip it from the top, or unclip the top. There we go. And then withdraw the top a bit, enough to get that antenna out. Oh, that took some doing. And don't lose his screw. Wow, that's immaculate. So what we need to now do is to find our... Oh, I don't even know if we've got one. We probably once did a 2.5mm cable so we could run it off the power supply off 12 volts. Remember, it's a 12 volt radio. It is not 13.8. And that's why you've got two dummy batteries. If you're running it on throwaway alkaline batteries, then you put 8 in and 2 dummy batteries. Dummy batteries are readily available on eBay. So you've got 12 volts because 8 times 1.5 is 12 volts. If you use rechargeables, they're 1.2 volts per cell, so you put 10 rechargeables in. And at the time these were made, it was intended for nickel cadmium rechargeables, and it was at a time when there were 500 milliamp hour was the maximum capacity. So these draw about 1 amp on transmit, so 20 minutes and the set's going to be flat, isn't it? So there you go. I think there's 2 watt set these, but we've got the. No wonder it's stuck. What's all this stickiness on there? We've got the service manual just coming off the printer, so we'll leave it at that, and I'll go and see if I can find a 2.5mm plug, because I don't really want to power it up. Oh, you know, we'll power it up from the battery thing. That'll do. That'll save me some time. So what we use is the Alba CBH2 service manual, which of course is also good for the Harrius, was it the WT2? So this is the only service manual I ever found. Harvard would have done one, I'm absolutely sure, but for some reason we didn't end up with one. Right, so, or was the Alba one cheaper? I think we'll see. I think we'll get a piece of paper and write down how this is performing. And before I finish this video, I think it'd be sensible to also look at the other sets, and we'll compare the way they perform before this video ends. So I'll be doing those other 2 behind the scenes. You look well if the most immaculate one's the worst, and the worst one's the best. So we will write down Harvard 410T, and we'll start with 50590 yellow. So I'll get what I do need is the antenna adapter, and it's a 3.5mm jack, and a little pot of adapters. We've got the RCA one, but I see no 3.5mm one for some reason. Pause the video. Okay, I've had to waste some time making up a lead because I can't find our adapter. I better put some on order again. So I've got a 3.5mm plug, which looks like it's on cross-threaded. What stupid fool would do that? That looks better. And to a PL259 into a PL258, so it interfaces with the equipment. I don't expect it'll work any worse than an adapter. So what happened to the previous lead and what happened to the previous adapter? Because we had both. Perhaps I keep giving them away to customers. Right, so we'll connect this up to power. And we'll plug the adapter into there and switch on. And we're on channel 9 because the channel 9 button was pressed. So we better put the display on, which is the red one. Oh, perhaps it is on channel 9. No. Aha, I've done it. So we're on channel 20. We'll switch picture in picture on and we'll see whether it transmits. Oh dear. So it does transmit and it's doing 2.3 watts. deviation. Wallop. What? Oh dear, this is going to be fun, isn't it? Wallop. 1, 2. These 3 may need to have to come down because it really doesn't want to be going beyond 2.5. So let's see how the sensitivity is working. Now there isn't an earphone socket, is there? So I can't do a before and after on that. It means dismantling the radio to do the tune-up. I knew there was a reason I didn't like them. And just for a laugh, it's gone off as well. Listen to that for bleed over on S9. So I'm giving it an S9 signal and it's reading, I can't even read that. Changes glasses. It says about S6. That's 1 microvolt. I say we can't see what the synad is. So I can, the absolute best I can hear is 0.3 microvolts, and that's with my ears, and that's 0.3. I'll tell you what, we'll do the frequency, that's easy. So 27,79078 needs to come up to 79125. 27,79078. $27,79126. So it wasn't out of tolerance, but it wanted bringing up. So how many watts is the radio supposed to do? It's supposed to do 2 watts, and the limit spec is 1.8. So it already exceeds the transmit. And that's into our test set. So, what are we looking at? We are looking at T2, 3, 4 and 5. Probably those. So you get to the layout and none of the components are numbered. Isn't that clever? Yeah, 2, 3, 4 and 5. T1 of course is the antenna loading coil, so I'm glad I didn't touch that. In fact, and I've written it down anyway with some extras. 2, 3, 4 and 5. So that's what we'll do. I'm struggling with the connection on this. I don't know whether it's dirty in the socket. So we're at 2.1 as it's warmed up. So we'll go through. Peak. 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 So yeah, it's about there. We'll do the antenna one later when we're going to, with the telescopic aerial, check for field strength. So transmit is excellent. Now if we can hold our little oscillator somewhere near the microphone. I really need to come down a fraction. So just remind myself where deviation is. It is VR1. Why don't I just write on that? Done. Probably about there. Wallow. Want. You still make it go over, but I think that's about average. I'm not sure how the limiter works on that. So I've definitely set it for 2.2. It's 2.3 watts. Put that away. Current consumption is half an amp. Just look where it should be. Yeah. They expect it to be 650 milliamps, and the worst it should be is 750 milliamps. So we're well in there, that's great. Out of interest, we'll just see what low power does. And it's 210 milliwatts. Now there's going to be a meter preset, I expect, for the transmit meter. So I'll just look at the circuit diagram, which isn't that good. Oh, it might be in the. It might actually be in the blurb. So I'll read the blurb first. Modulation, receiver, transmitter. Oh, what they tell you to do is to press the call button, because it has a call button. Let me put my monitor receiver on. And they tell you to set the deviation to that. Wallow. Now it's too loud. One, two, testing 1, 2. So I've set that to 2. So that's a nifty way of doing it, to be honest. I wouldn't have thought of that, but there you go, that's me. I don't know if I can even read this, it's such a poor copy of a copy. So I'm trying to look for, I can see VR2 looks to be a Squelch preset. Okay, so what I've done, I've had to solder a wire onto the speaker positive. There's just nothing for a crocodile clip to grip. So we've now got it on the cyanide meter, and I'll put that on the picture-in-picture. And that's 12 dB. So we can now take a reading, and it is 1.3 microvolts for 12 dB. So let's see what we can now do. So we'll go through this. Yeah, you set your signal generator for 1.4 kilohertz deviation. Somebody asked me that. It says 1.5 in this manual. It's going to differ from manual to manual. It's 1.4, so it's not like the maximum of 2 point something or other. It's what they call internal modulation is shown on this meter. I could show you. So anyway, here we are. Transformer 7 and 8 for maximum audio output. Seven and 8. It's quite a simple receiver. There's not a lot there. So which is the detector? It doesn't not as I can see this dreadful circuit. Okay, 7 and 8 it is. So we're looking at those two. No, I don't think it has a normal discriminated coil. Okay, so we'll drop this to 4 decibels and adjust 7 and 8 as the book says. Just turn that volume up a bit and annoy all those who are annoyed by a bit of a noise. It said maximum audio output. Let's put it to 12. Might be better to adjust them. Yeah, it is. Right, we'll get some new figures. I didn't see any actual difference, but we'll nevertheless see what it all says. Just turn the volume down again. So, let's see if we can get 20. We can. And 20 is 3.7. 12 is now, oh yeah, 1.3 microvolts. Hey, it's not changed at all. Yeah, not changed at all. And 10. Wow, we're just between scales like we often are. Is 1 point. I'm not going to say 1.1 because it isn't. 1.15 microvolts. So let's look at the S meter. So it should be reading S9, and we need to adjust VR5 down there if it isn't doing. But we'll unplug this. Oh, no, we won't. I'll put the tool in there ready. Could I put the tool in there ready? No, I couldn't. That's about it. Let's go back to transmit. I don't think it. I think it's just a battery meter on. Oh, let's go on to low power. That will prove it, won't it? Yeah, it reads the same. So, Squelch is the next thing. So we'll turn the Squelch. This is where these are really let down. So that's 10 microvolts at the moment. Just prove that this is the Squelch control. Oh, that is harsher. Okay, so we've got it as harsh as we can. So the best I can get out of it is 6 microvolts full Squelch. And at the sensitive end, turn the signal generator off, park it at 0.3. Switch the signal generator on. So it's coming on at 0.65 microvolts, dropping off 0.3 microvolts. So the sensitivity is there at the sensitive end, but don't expect to use this as a base station especially in a built-up area. However, we're going to be using it as a base station when we do the on-the-air test, but not with this one. We'll do it with the other. So that covers everything. And now the phone's ringing. Alright. So, it was Bob on the phone, and he shouldn't be phoning me. He's very short of money. He's a retired pensioner, and he shouldn't be phoning me in the afternoon on full whack phone call charge, because I certainly can't afford to phone him back on it, and I'll phone him back at 7 when it's cheap rate. So, we're going to use this to do field strength, because it's got a field strength thing on it. And I'm going to adjust the coil just there, which is the antenna loading coil, so we can do that. Now I'm going to have to get this in a position. I think I know what we're going to do. We're going to screw that board back in. Okay, so going back into record, I've just set this up with the aerial's at full. It's nearly poking the eyes out of the overhead camera, and I hope when I key it up it doesn't cause interference to that camera. So when I key it up, I've set this so that I'm getting a reading. That's all it's about. It's a relative reading. And so now we'll get the appropriate tool into that coil. And the power lead comes off. So there we've got it. There's a little bit more field strength than there was before, and that's how we optimise the range on that. So it's with telescopic fully up, and with the antenna loading coil, we're just looking for peak radiated power. So there we are. That's done. So I'll put it back together. Okay, we've got pretty dismal receive on this one. It's receiving, but it's pretty dismal. And this is the yellow immaculate one. And when we actually look inside it, I notice the screws were rusty. When we look on the printed circuit board, it's just covered in corrosion. I'm surprised it works at all. So what I think we'll do is to go over that with the fiberglass brush. I wasn't going to feature two of these sets, but this is in such a precarious state that although it works now, what you don't want to happen is for it to go back to the customer and it doesn't work. And then go, I've just paid you £1 million and it doesn't work. So we'll get the expensive RS fiberglass brush. I think if this was my own set, I would have disconnected the speaker and meter, taken what I could out of the case, and I'd have put the whole thing in isopropyl alcohol in a ultrasonic cleaner. But it's not my set, and then if something melts, you know, you look well if my set is as bad. So I'll take a break while this dries. I know it's pretty quick to dry, but I'm putting quite a lot on so it drains out at the bottom. So that certainly looks a lot better. Incidentally, this one I had to turn down. It was doing 2.5 watts. I don't really want it to do more than 2.4 watts. Or A, you're thrashing the output transistor, and B, you're drawing excessive power consumption. So let's see whether we can put this back together. So we'll go over to my one finally, and it works just as well or as badly, however you want to say it, as all the others. Mine's a bit scruffier, but the aerial's intact and I've done everything. Now the customer who owns the one we've put the purple stickers on, pink stickers, that's the one with the water damage. He sent this mains adapter. This is not going to be right. This is for charging. And what we need to do is to see whether it will, I don't know how it's connected. In other words, whether you can run the set from an external input if you take the batteries out. See what I'm getting at? Because if you are charging, that's a charge socket, it should only charge the batteries, in which case it should be 50 milliamps at around 15, 18 volts, something like that. That's what it should be. If that socket also enables you to power the radio, then the batteries would have to come out, or at least one battery would have to come out, because otherwise you would be charging the radio at the 1 amp which it is going to require to be powered by. Certainly it's going to be at least 800 milliamps. So we're going to find out on my set. We're not going to blow up the customer set. We'll blow up my set. He sent this mains adapter, and it's all so small, this writing. I just cannot see this doing 12 volts at 1 amp. No, it doesn't. It's 300 milliamps. So it isn't suitable as a charger because it's too hefty, and it isn't suitable to run the radio, except on receive, because it isn't heavy duty enough. And it doesn't say, I can't see that it says whether it's regulated or not. Normally when something says it isn't, normally when something says nothing about regulation, then you assume it isn't. So we'll plug it in. This is going to be fun because the cable comes out the top and my socket board is 2 plus 2 facing each other, which is going to be interesting. We're going to have to unplug something. It's what that something is. I'm going to watch all the picture go out. Yeah, my monitor's gone off, so I now can't see what we're doing. So we'll guess what we're doing. You know what? I bet I can plug the monitor into another socket. It's just I wanted that particular socket for that shape of adapter. Hey! So, if this is regulated, it'll be more or less 12 volts. If it's unregulated, it'll be something higher. So we're on the 20 volt range. Negative. Right. Well, that's a good start, isn't it? Well, it doesn't even work. So, if we turn the selector because sometimes you've got a dodgy contact. So now we'll try it again. Yeah, so it is regulated. It's doing 12 volts. So that was suffering from a dodgy contact. So here comes the thing. We are not going to press transmit on this because it would damage something. So it will power the radio, which means that because that voltage is available at the battery terminals, and we'll just prove it. There's going to be a resistor to restrict the current flow. So that means you probably can use it to charge batteries if it's got internal, if the radio's got internal, not regulation, but just a resistor. But it's the wrong thing, because it needs to be more than 12 volts to charge the batteries. It needs to be about 15 to 18 volts to charge the batteries. So it is totally the wrong thing, and he can use that on on his transistor radio, probably. Good, well, we've got to the bottom of that. So that's 3 sets done, and we'll do an on-the-air test as soon as Mr. C becomes available. And I'm going to have to power it with some kind of jiggery-pokery, or put 8 or 10 batteries in. We'll see. Thank you for watching the Harvard 410T walkie-talkie servicing from 1981.